Hi sir, good afternoon to all of you. This is K. Ishwant from CSC Data Science second semester, and my roll number is the 24951A and 6763. Today my topic is double integrals, which is belongs to the differential equations and vector calculus. Now let us discuss about the double integrals briefly in this presentation. Double integrals. What is the introduction of double integrals? Double integrals extend the concept of single integrals to the functions of two variables. They are used to compute the volume under a surface over a given region in the xy plane. Understanding double integrals is essential for applications in physics, engineering, and the statistics. First, double integrals. What is double integrals? Double integrals are the concept of single integrals to functions of two variables. A function which consists of two variables, it is called as a double integrals, and they are used to compute the volume under a surface over a given region in the xy plane. When we want to find the volume under a surface which is in the xy plane, we are use the double integrals. Next, when we understand the double integrals, it is essential for applications in the physics and engineering and the statistics and many other subjects. We can rewrite some double integrals as a product of single integrals as given on the presentation. We won't be able to use this theorem all the time. It has two important requirements. The above problem has required two important requirements. First one, the bonds of integrations ABCD are constant. We will see integrals soon where this is not in the case. Second one, the function can be factored into function of x times a function y, but the most two variable functions cannot. Next, we are going to another slide. Definition of double integrals. Here there are brief definition of the double integrals. A double integral is represented as a double integration of r into f of x comma y, where r is the region of integration. Here r is denoted with the capital letter. It is defined as a region of integrations. It computes the accumulation of values of the function f over the area A. Here r is called as a area and f is called as a function. The differential area element dA can be expressed as dx or dy or dy dx depending on the order of integration. When the order of integration is different, the differential equation also expressed as a different way, like dx by dy or the dy by dx. It is depend on the situation and order of integrations. Next, geometric interpretation. Here the geometric interpretation of the double integrals as visualized on the above screen. The double integral can be visualized as the volume beneath the surface z is equals to f of x comma y. It is one of the formula for volume beneath the surface z. The region r in the xy plane represent the limits of integration. The geometric view helps in understanding the physical significance of double integrals. Here the geometric view which helps in understanding the physical significance of the double integrals. This graph has shown that the area which is with the blue mark, it is called as a integrating area, which is denoted by f of x. And then we go to another slide setting up the integrals. To set up a double integral, first identify the region R over which to integrate. To set up a double integral, when we want to set up a double integral, first identify the region R which is over to integrate. First we have to identify the region. Next, the limits of integration depend on the shape of the region. For rectangular region, the limits are constants. For more complex shape, there may be functions of x or y. Different shapes, the limits are very different, and for the rectangular region the limits are constant. And another complex shapes, they may be x or y, but in the rectangular region the limits are always constants like a or b, etc. Evaluating of double integrals. When we want to evaluate the double integral, there is one of the method that the method has displaying on the screen. Double integrals can be evaluated by iterating single integrals. Choose the order of integration x dx dy or dy dz based on the problem context. Yes. The evaluation involves first integrating with respect to one variable, then the other. The evaluation of first integrating with only one variable only. Then after evaluation of one integration, then we can proceed with the another variable, then the other. Next, the improper double integrals can often be computed similarly to improper integrals of one variable. The first iteration of the following improper integrals is conducted just as if they were proper integrals. One of them evaluates an improper integral of a single variable by taking appropriate limits. As in section 8.8, evaluate improper integrals in exercises 69 to 75 as iterated integral. The above 69 to 72 integrals are called as improper integrals. So the evaluation process of improper integrals also another is a very different. Next, change of order of integration. To integrate one of the integration, we have to change order of the integration because of sometimes it will be differ and it is very difficult to evaluate. So that's why we have to change the order of integration. Sometimes changing of integration simplifies the computation. This involves evaluating the limits of integration based on the new order. A careful sketch of the region can aid the determining the new limits. The above graph as shown here. Then here they have changed the order of integration. So this is the process of changing of order of integration. Then polar coordinates. Double integrals can be computed in polar coordinates for circular regions. The conversion involves substituting x is equals to r cos theta and y is equals to r sin theta. The area element changes to dA is equals to r dr d theta, which accounts for the geometry of polar coordinates. Polar coordinates which is double integrals can be computed through the polar coordinates for only circular regions. Example, rectangular region. Consider the double integration of r into x plus y into dA over the rectangle of 0 to 0 comma 1 into 0 comma 1. Setting up the integral gives integration of 0 to 1 and integration of 0 to 1 into x plus y into dy by dx. This is the one of the problem which has given on the screen. Here we have solved this problem. Consider the double integral. First we have to consider the double integral and where r is the region in the xy plane bounded by y is equals to 0 and y is equals to 4 and x is equals to 0 and x is equals to under root 4. These are some of the problems are displayed on the screen. Next, one of the example for non-rectangular region. For a triangular region with vertices at 0, 0, 1, 0 and 0, 1, we set up the integral. The integral becomes integration of 0 to 1 and integration of 0 to 1 minus x into 1 into dy by dx. Here evaluating this gives a value of 1 by 2 representing the area of triangle. Applications of doubling. What are the applications for double integrals? Double integrals are widely used in calculating areas, volumes and mass distributions. They also appear in probability, especially in finding joint distributions. Engineers use double integrals to model physical systems and optimize designs. So mainly the main applications of the double integrals is to find and calculate the area, volumes and mass distributions. They also appear in the probability, especially in finding joint distribution. When we want to find the joint distribution, the double integrals are very useful to find it, and engineerings can use the double integrals to model physical systems and optimize designs. Next, mass and density. When dealing with mass, double integrals can help find the mass of total region. If f of x comma y represents density, the mass m is given by m is equals to double integral of r into f of x comma y into dA. It is the formula for finding of mass. Next, this application is crucial in fields such as material science and engineering, and also sometimes in physics we are using this formula. Let f of xy be the density mass per unit volume of a distribution of the mass in the xy plane. Then the total mass m in the r is m is equals to double integral of r to f of x comma y into dx comma dy. The center of gravity of the mass in R has the coordinate x bar comma y bar, where x bar is equals to 1 by m double integral of x into f of x comma y dx by dy, and y bar is equals to 1 by m into double integral of y into x comma y into dx by dy. These are the main formula for mass and density and center of gravity and the total mass. Next, average value of a function. The average value of a function over a region can be computed using double integrals. It is defined as a 1 by a into double integral of r into f of x comma y dA, where a is a region R. This concept is useful in statistics and data analysis, mainly for the data science students. The data analysis is very important. Fubini's theorem. Fubini's theorem states that under certain conditions, the order of integrations can be interchanged. This is particularly useful when evaluating double integrals. It simplifies calculations by allowing integration in a more convenient order. In iterate integrals. An iterate integral is a way of expressing a double integral as two successive single integrals. The form is written as integration of underscore a to b integration of c to d f of x comma y into dx of dx. This method emphasizes the step-by-step nature of evaluating double integrals. Common mistakes. Some of the students are making common mistakes is to incorrectly identify the limits of integrations for the region. Failing to account for the order of integration can lead to incorrect results. Proper visualization and sketching of the region can help avoid these errors. The mainly common mistakes are: first one, incorrectly identifying of limits of integrations, and second one, failing to account for the order of integration, and the proper visualization and sketching region these are the mistakes. Software tools. Various software tools can assist in calculating double integrals. Programs like Mathematician, MATLAB, and Python libraries can automate the process. Learning to use these tools can enhance efficiency in solving complex integrals. Nowadays, the software tools also developed for calculating double integrals. Programs like Mathematica and MATLAB and Python. Next, summary of key concept. The total summary is double integrals generalize single integrals to two variables and have geometric interpretations. They are evaluated over regions in the xy plane, and various techniques can simplify commutations. Understanding double integrals is crucial for application in multiple disciplines. Further reading and resources. For deeper understanding, consult Advanced Calculus and Multivariable Calculus textbook. Online platforms like Khan Academy and Coursera offer courses on double integrals. Engaging in practice problems and exercise will reinforce these concepts effectively. Feel free to customize any of the content or structure to better fit your presentation. Thank you for giving this and wonderful opportunity to describe about the double integrals and total the properties and the examples of the double integral. Thank you.